My dear student, how are you? I think all of you are well, staying at home. Today, I am going to conduct another class on physics. So, welcome to Amader Pashala, presented by Manipur Uchcha Vidyalaya and College. My dear student, you have seen a common picture. If you attend my previous lecture, you have already seen this. This is a figure or the image of supplying electricity in modern civilization. So, easily you can guess what we are going to learn today. Now, before going to our lecture, just I want to remind you, that means I want to give the review of our previous lecture, lecture 1. In this lecture, we have learned so many things about electricity, that is, what is electricity, why does electricity produce, how does electron flow from lower potential to higher potential, and then finally, by knowing Ohm's law, we have established the relation between current and the potential difference of a conductor. For your kind information, this is again for you. At constant temperature, the current flowing through a particular conductor is directly proportional to the potential difference between two ends of the conductor. My dear young learners, you already know this. This is a conductor having two terminals A and B, and the potential of these two terminals are VA and VB. If VA is greater than VB, that means is the high potential, then potential difference will be VA minus VB. According to Ohm's law, you know that current I is directly proportional to potential difference. Then mathematically you can write I equals to GB, where G is the constant of proportionality and known as conductance. Then the reciprocal property of this conductor is R. You know that this R is basically represent the resistance. Then G equals to 1 by R. Putting the value of 1 by R in place of G, you will get V equals to IR. So, this is the mathematical formula of Ohm's law. From this law, you can find the relation between potential difference, resistance and current. Now, this is a simple circuit where only one resistance and on cell, or that is electromotive force, and from this equation, from this circuit, you can easily find out the value of current by using Ohm's law. But if any other circuit comes like this is another resistance and connected by a cell, this is another resistance 3 ohm connected source is on board, and another resistance 2 ohm having potential difference or electromotive force 3 volt. If these 3 cells and 3 resistance makes a complete path, that is a complete circuit, in this case it is very tough for you to calculate the corresponding current I1, I2 and I3 using Ohm's law. That means you cannot solve this problem using the combination of resistance or the combination of cells. In this case, you have to apply another law. So, this is our today's topics. Kirchhoff's law. By using Kirchhoff's law, you can solve this problem. Chapter 3, current electricity, lecture number 2, and physics second paper for class 11 and 12. So, my dear young learners, our today's topics, Kirchhoff's law. What are the learning outcomes of our today's lecture? At the end of the chapter, the student will be able to know about Kirchhoff's law, how does and at what ratio electricity flow in a complex circuit, and what about the Wheatstone bridge, and finally, they will be able to solve some mathematical problems that helps them to make a better result in the examination. Now, basically Kirchhoff's law are of two types, that is they are denoted by first law and simply known as junction law, and second one is loop theory. Between them I am going to discuss at first the first law, that is junction law. This is a junction, you know, junction O is the junction point. Here junction combined 1, 2, 3, 4, 5 wires, and this junction law deals with what amount of current basically exists or deposit here. From this figure, my dear young learners, you see I1 is the incoming current, where I2 is the outgoing current, and I3 also outgoing, and I4 also incoming, and similarly I4, 5 also incoming. So, what will be the total current at this junction? Will there produce any current in this junction, or this junction will act as the depositor? No. The total current of this junction, that is the algebraic sum I1 plus minus I2 plus minus I3 plus I4 plus I5 equals to 0. Here I mentioned minus I2 and minus I3 depending on its direction, because I1, I4 and I5 are the incoming currents, and I2, I3 are the outgoing currents. That means incoming current equals to outgoing currents. So, it is very clear to you that the junction does not maintain act as the depositor, or it does not produce any electricity. So, in mathematically this is the equation, but linguistically you can say that the algebraic sum of current in a junction of an electric circuit is 0. That means total current at the junction will remain 0. Now, about second law, and the second law is known as the loop theory. What basically says in loop theory? You know that in a closed circuit, the algebraic sum of the product of resistances of different parts and their corresponding current is equal to the total electromotive force of the circuit. My dear young learners, you have to note 2 or 3 keywords in this law, that is the algebraic sum and the product of resistance and their corresponding current, and finally this equal to the electromotive force. That means product of current and their algebraic sum will equals to the electromotive force. To know, to get the clear conception or to apply loop theory, you have to follow some rules. Some rules are to follow to apply the loop theory. So, what are the rules to solve any circuit using loop theory? This is the first rule. The direction of flow of current from higher potential to lower potential, you know this, the direction of current from lower potential to higher potential. This is the conventional rule. So, for this case the product of current and resistance will be positive, and for negative for this reverse direction. But student, there are 2 or more rules depending on this situation. I just mentioned one rules. You have already learned book that is clockwise rule, anti-clockwise rule, and something else. But I think this is very clear for you. This is a related topics for you. And the second rule is the direction of EMF of a cell from negative terminal to positive terminal. EMF, that is electromotive force that supply the energy, that sends the electricity to the circuit, and its direction is from negative to positive terminal. That is, so in the direction of EMF we consider the direction of current. So, direction of current and direction of EMF are equal. Then EMF is considered as positive, then we consider the direction of current will be positive. And if we consider the direction of current is against the EMF direction, then EMF will be negative. That means, along the direction of EMF, along the direction of current, this is positive, and if reverse occurs, then it is negative. Now, this is a complete circuit. I use this circuit to make these 2 laws very clear to you. This is a complete circuit because this circuit contains 2 cells, E1 and E2, and also contains 3 resistance R1, R2 and R3. In this case, you also see that current I1, I2 and I3. So, this is a complete circuit. In this case, just I am going to apply Kirchhoff's law, second law. For this, you have to first consider a loop like A, B, C, D. This is a closed loop, A, B, C, D. In this case, A, B, that is the direction of current, and I am going to this direction. So, the product of current and resistance, that is I1 and R1, and this is current I3 and R3. So, product is I3 and R3, and this is the algebraic sum, which is equals to electromotive force E1. So, this is the application of loop theory. I am going to apply loop theory in another loop, that is D, C, G, F, D. This is another closed loop. In this case, you can easily apply this, that is I2 R2 plus I3 R3 equals to E2. So, this is the applications of loop theory. Again, then mathematically you can write summation over IR equals to E2. This is the algebraic sum or the summation over of potential difference, product of potential difference and resistances. Now, we have learned already loop theory, but by using loop theory, how can you calculate the current I1, I2 and I3? In order to know these, just you have to follow this lecture. And suppose at point D, I just apply the junction law. It is the junction law. In this case, you see clearly that this I1 and I2 are outgoing current, and this is the I3 incoming current. So, you can write incoming current equals to outgoing current. This is equation number 1. Now, you apply loop theory on these loops A, B, C, D, A. As before, I have discussed this, that is I1 R1 plus I3 R3 equals to N. Putting the value of R1 and R3, in this case R1 equals to 2 and R3 equals to 5, and also you have to place I3 equals to I1 plus I2, so that I get an equation related to I1 and I2. Then from this equation, mathematically you can write 7 I1 plus 5 I2 minus 3 equals to 0. This is equation number 1. Now, you can apply another loop, you can consider another loop, that is D, C, G, F, D, another loop, and you can apply this loop theory as before. But in this case, I did not mention the resistance R1, R2 or R3, simply I use the value of these resistances R2 and R3. And in this case, you also have to write R3, in place of R3 you have to write I1 and I2. Then mathematically you can write 5 I1 plus 6 I2 minus 1.5 equals to 0. This is equation number 2. So, my dear student, you have got two equations. Then by mathematically simply you can get the value of I1 and I2. The way is that if equation 1 is multiplied by 5 and equation 2 is multiplied by 7, then you will get 35 I1 plus 25 I2 minus 15 equals to 0, which is denoted by equation 3. And from equation 2 you will get 35 I1 plus 42 I2 minus 9 equals to 0. Now, the equation 4 subtracted from 3 or 3 subtracted from 4, you will get the value of I2. And you, by putting the value of I2 in any one of this equation 1, 2, 3, 4, you will easily get the equation value of I1. But in this case, I put this value of I2 in equation 1 and get I1 equals to 0.6806 ampere. By knowing the value of I1 and I2 from equation A, you can finally easily get the value of I3. Just I have done this, I3 equals to this value, that is 0.3277 ampere. In this case, you have got all these three values of I1, I2 and I3 by using Kirchhoff's law. My dear student, you have to know that where you can use Kirchhoff's law, you cannot use their Ohm's law. But in place of Ohm's law, you can apply Kirchhoff's law. Try it at your home. Now, application of Kirchhoff's law, that is in which case we use Kirchhoff's law. This is a resistance P, another resistance Q, these two resistances are in series combination, another resistance R, and the last one is S. So, these are the four resistances are in series combination, makes four terminals and these two terminals are B and D, and these two terminals are connected by a galvanometer of resistance Z having a key Q2, and another two terminals A and C is connected by a source and rheostat and another key Q1. If then in this case basically the current I in this cell supply the current I, and this I at point A will be divided into two portions, I1 and I2, and when I1 passing through this resistance at point B, if the B point is higher potential than the D, then from this point the I1 will divide it into two portions, that is IG galvanometer current, and rest of part will be I3, and this galvanometer current IG and this current I2 at point D makes current for I4, and this I4 current will passing through the shunt resistance S, and finally at point C I3 and I4 again makes the total current. So, this is a circuit where the two terminals are combined by a galvanometer and rest two terminals are connected by a source. This circuit is nothing but known as the Wheatstone bridge circuit. In this circuit, basically these four resistances are arranged in such a way that no current flow through the galvanometer when both key K1 and K2 are closed. This condition can be proved only by using Kirchhoff's law. So, this is our application. That means you have to arrange these four resistances P, Q, R, S so that B and D point will remain the same potential. That means no current flow through the galvanometer. This is a balance condition of the Wheatstone bridge, and this condition can be proved from Kirchhoff's law. Now, I am going to establish this relation. This is the same circuit again, and now you consider first law at point B. In this case, this is the incoming current I1, outgoing current Ig and I3. Then you can write I1 equals to Ig plus I3. At point D, you can write similar way first law, that is I2 incoming and Ig incoming, only I4 outgoing, that is I2 plus Ig equals to I4. This is the outgoing current. Now, we consider the loop, that is Kirchhoff's second law, A, B, D, A. This is a closed loop. In this case, I just use, my dear student, I use here the clockwise rule. As before, I have done a normal method, but in this case, I used a clockwise rules. In this case, current A, B, that is the clockwise direction. This will be the negative, that is the product of I1 and P. This will be negative, and this is IGZ. This is also the direction of clockwise direction. So, this will also be negative, but D to A, this is the clockwise, but the current indicates the opposite order. That is why this will be the I plus I to R. So, this is the clockwise rule application. Now, we consider another loop, that is B, C, G, B. In this case, similar way, you can write minus I3Q plus I4S plus IGZ equals to 0, which is equation number 4. So, my dear student, you have got 4 equations on Wheatstone bridge, but in balance condition, no current will flow through the galvanometer, that is Ig will be 0. Now, apply Ig 0 on the last 4 equations. Then from equation 1 and 2, you will get I1 equals to I3 and I2 equals to I4. This is equation number 5. That means, if you put Ig equals to 0, then equation 1 becomes, and this is equation 2, which is denoted represented by another equation, that is 5. Now, we have to apply Ig 0 in equation 3 and 4. Then equation 3 becomes I on P equals to I to R, which is denoted by equation 6, and now equation 4 becomes I3Qs minus I4S equals to Z, which can be written as I3Q equals to I4S. Now, dividing equation 6 by equation 5, equation 6 by equation 7, we will get I on P by I3Q equals to I2R by I4S. But equation 5, you know that I1 equals to I3 and I4 equals to I4 5. Equation 5 basically says I1 equals to I3 and I2 equals to I4. So, this I1 and I3 will be cancelled. Similarly, I2 and I4 will be cancelled. Therefore, you can write the equation P by Q equals to R by S. So, this is the balance condition. That means, in order to get balance condition, you have to arrange the 4 resistance on this ratio. That means, ratio of PQ must be equal to ratio of R by S. Then, no current will flow through the galvanometer. That is the balance condition. Now, my dear young learners, do some mathematical problems to make the clear sense. So, in a Wheatstone bridge, there are 4 resistances of 5, 15, 20 and 100 ohm respectively, that is P, Q, R and S. At what amount of resistance is to be connected to the 4th arm of the bridge to make it balance? That means, you have to get a balance circuit by rearranging resistance at 4 terms. That means, the resistance that is given here is not the actual value. Just to make balance, you have to get the actual value of 4th resistance, that is S. So, what is the given solution? Resistance of first term P and the second term Q, third one R and the 4th one, my dear student, this is not the exact value. So, you cannot write it S, you have to represent it S1. So, S1 equals to 100 ohm. Now, you have to find the exact value of S. What will be the appropriate value of S to make it balance? Now, just use the Wheatstone bridge formula, that is P by Q equals to R by S. In this case, P, Q and R, putting the value of P, Q and R, you will get S, and similarly S equals to 100 ohm. My dear student, this is the turning point. Here the required value is 100 ohm, but the given value is required value is 60 ohm, but the given value is 100 ohm. How can you rearrange this? You know that if these resistances are in parallel combination of resistances gives the less equivalent resistance. So, you have to arrange something with the parallel combination, then 1 by S equals to 1 by S1 plus 1 by S2. Putting the value of S and S1, you will get S2 equals to 150 ohm. That means, in this case, you have to connect 150 ohm resistance, 150 ohm resistance in parallel combination to make it balance. Now, another problem for you. This is a simple circuit for you, and 4 resistances are 100 ohm, 3 ohm, 24 and 60 ohm. At what amount of resistance is to be connected to the first term? My dear student, in this case, I have to verify the first resistance, that is first 100 ohm. That means, 100 ohm is not the exact value to make it balance. You have to verify 100 ohm, whether the required value is 100 or more than 100 or less than 100. But you will get from this equation. So, resistance of first term P1 equals to 100 ohm. Here I write P1, not P, because this is not the actual value. And the second term Q equals to 300, and the 4th term R equals to 24, and the third one and the 4th resistance is 60 ohm. Now, using formula P by Q equals to R by S. In this case, you have to find out the first term, that is P. Putting all these 3 values, rest 3 values, that is 300, 24 and 60, you will get P equals to 120 ohm. That means, here the required resistance is 120, but given resistance is 100 ohm. That means, required resistance is more than the available resistance. But you know that to get more resistances, we basically combined a series combination. That is, by series combination, we get more resistance. So, you have to series some amount of resistance with P to get the required value. That is, P equals to P1 plus P2. Putting the value of P and P1, you will get P2, that is 20 ohm. That means, you have to connect 20 ohm resistance in series combination to make the circuit balance. Now, we just have reached at the last of our destination. So, as usually, I am going to give you a homework, and this homework is related to our today's topics that we have already learned. My dear young learners, you have seen this is a Wheatstone bridge, and here the resistance is 150 ohm, 100 ohm, 20 ohm and 10 ohm. So, source is 10 volt. So, what are the available question here for you? Number 1, what is circuit? Number 2, explain the balance condition of the Wheatstone bridge principle. Already I have told it in my lecture. And the third one is what amount of resistance is to be connected to its second arm to make it balance. That means you have to verify PQRS, that is Q. You have to verify Q, whether the resistance Q is accurate or not, and you have to find out the value of Q. Then you have to make a decision whether this resistance will be connected in series combination or in parallel combination. And the last one is, will there be any relation between the ratio of currents and resistance of ABC part and ADC part of the equilibrium? That means, just in our previous slide, that you have to calculate current ABC and ADC. This is the ABC. You have to calculate current along this path and along this path, that is ADC, and you have to establish any relation between the given resistance and the calculating current, and this is your problem. I think you can do it very clearly as you have learned my lecture. So, no more today. Thanks all. Thanks to join our class.